Hey, everybody. Hope we're all doing well. So this is the Section 11.8 Day 2 video. Winding down to it. So grab your guided notes from the link above, and let's get started. So in the beginning, in the lesson we did the other day, which I just recorded like 2 seconds ago, we did Section 11.8 Day 1, which was multiplying. Now Section 11.8 Day 2 is going to be dividing. And it's not really actually dividing. Well, you'll see here in a second. Okay. Now, a quotient, well, remember quotient means to divide. A quotient or fraction with a square root in the denominator is technically not simplified. So if I take something like, I've got the square root of 3 and I want to divide it by the square root of 2. Somebody made up this rule a long time ago that when you have a square root in the denominator, it's not simplified. Okay, it's not simplified. To simplify these expressions, we want to do this thing called rationalizing the denominator. Radical 2 is an irrational number, and we want to make it rational. We want to rationalize the denominator. We want to turn it into something that's a rational number. Well, the easiest way to do that, well, what removes the radical sign? Well, what if we square it? What if we just multiply it by the same thing? Okay, that would do it, right? The square root of 2 times the square root of 2 just gets us a 2, right? We talked about that in the last lesson. We could call it the square root of 4, but it would be just turned back into 2. Now, I can't really go ahead and just like multiply by anything I want. I can't change the fabric of the number, so I just want to multiply by 1, or radical 2 over radical 2. Wouldn't we agree that that is 1? If we have the same thing over itself, isn't that just 1? Okay, well, what's radical 3 times radical 2? Radical 6. And that is rationalizing the denominator, people. We take the radical in the denominator and we multiply it up to the numerator. And whatever we do to the bottom, we must do to the top. Okay, that is called rationalizing the denominator. So let's do that. Okay, so here's what we have. We have a square root in the denominator. Now, what we have to look for is we have to make sure that nothing can be simplified down. And there can't. Like I can't reduce down radical 11. I can't reduce down radical 3. So what we do is we multiply by 1. But really just take the radical from the denominator and multiply it by both numerator and denominator. Because again, this number here, radical 3 over radical 3, is just 1 in the end. So we've got radical 11 times the radical 3, which is a radical 33, divided by, now we could call this radical 9, and maybe I'll do that for one problem here. I'm putting an extra step in there. You don't have to put this radical 9. You can just go straight to calling it 3. But that's my answer there. Okay? All right. So that's rationalizing the denominator. We're turning the denominator into a rational number. Okay? Let's try it again. So first thing I've got to check is, okay, is radical 13 reducible? No. That's a prime number. Is radical 5 reducible? No, that's a prime number. So we multiply the numerator and denominator by the radical in the denominator. So this turns into radical 13 times 5 is 65. And then we just have a 5 down below. Radical 5 times radical 5 would be radical 25, which is just 5. Now, I'd want to make sure that 65 can't be broken down at all. But that's just 13 and 5, which doesn't break down anymore. So there's no buddies to come out. All right, so there's my answer. Let's try another one. All right, now this is the first problem where I can break down something. I can't break down 13, but this 20 is reducible. 2 and 10, 2 and 5, I see a set of buddies that can come out. So this is radical 13m divided by 2 radical 5, right? Radical 20 gets into 2 radical 5. So here's what we do. We multiply by the radical that's in the denominator. I don't want to multiply by 2 radical 5. I just want to multiply by radical 5. If you multiply by that whole thing, by 2 radical 5, you're going to have to reduce more later, and you don't want to do that. So 13 times 5 again is 65m. And then the bottom we get, okay, so this is 2. We have that 2 sitting out front. And then a radical 5 times radical 5 would be our, and I'll write it here, why not? We could just go straight to saying 5, though. 65m over 2 times 5, which, again, can be reduced down to 10. There's my answer. Okay. Let's try another set. All right. Again, this is reducible. This is a 2 and a 6 and a 2 and a 3. So that can be broken down into, okay, I've got radical 7a. That does not reduce. but this is 2 radical 3. So what am I going to multiply by? The radical that's in the denominator, which gets me, okay, 7a times 3 is 21, and I'm multiplying those together because those are all on the inside. I can do that. And then I have 2 times, now I would say radical 9, but let's just make that 3. So I've got radical 21a over 6. And there's my answer. Okay. Square root of 21 cannot be reduced down. I'm good. Could I reduce down the square root in this one? No, but it is that 65 again. That's right. All right, so take a look here. First thing that I want to do is I see that now radical 7 cannot be reduced. That's a prime number, but I know 80 can be reduced. Radical 80 can be reduced into 2 and 40, 2 and 20, 2 and 10, 2 and 5. Okay, so that's square root of 1, 2, 3, 4 2s and a 5. Okay, so buddies and buddies make a 4 radical 5. So this is, since it's a 2 times radical 80, that'd be 2 times 4 radical 5, so 8 radical 5 over radical 7. Now that needs multiplied by the radical that's in the denominator. So that will get 8 radical 35. 5 times 7 is 35. Again, you just see this, 8 is on the outside. It just stays on the outside. I only multiply the two things in the radical together. So 7 times 5 gets me my 35, and then radical 7 times radical 7 is just a 7. There's my answer there. Last problem. All right, so let's break this down a little bit. Now this one's kind of interesting because if I break down radical 50x, that's 2 and 25, and then 5 and 5. So I have buddies with the 5, and that comes out 5 radical 2x. In the denominator, the radical 10, well, never mind, that doesn't reduce. Right? So I'm going to multiply by radical 10 over radical 10. The reason I say this one is a little bit tricky because now we get so 2x and 10 make a 20x. And in the bottom I get a 10. And now what I need to do is I need to reduce down the 20x. Reduce down that 20x. That gives me a 2 and a 10 and a 2 and a 5. So buddies with the 2. 2 radical 5x. Well, I had that 5. Don't forget about the 5. 5. 2 radical 5x over 10. And now that gives me a 10 radical 5x over 10. And look what reduces. The 10s reduce. So leaving me with just a radical 5x in the end. That's an interesting one. That's a kind of a difficult one. But all right, so I hope we're all having a good day. I hope division was not too bad as multiplication. Yeah, that's it. I know, it's just 2 slides. Easy notes day, right? Hopefully we're all staying happy and healthy. See you when I see you, folks.